All right, we are back here with Algebra 1. We are multiplying polynomials. Don't forget, hit like, hit subscribe, hit the bell. Don't forget, poly means many, nomials means terms. Before we get started, I just want to show this. This is the first time in 44 years that I have ever received flowers. And it was from one of my students because their class is kind of, their behavior's bad. Their class, his behavior's bad, and I kind of lost it yesterday, and it did come back, by the way. And they said people who get upset get flowers. And I've been upset plenty of times in my life. That's why my forehead goes back up here, but I've never got flowers before, so this is interesting. So I just wanted to share that little tidbit right quick. Okay, there are multiple ways to multiply polynomials. We're going to go over two. If you talk to somebody else that might be over the age of 30, they may mention this method, okay? FOIL. And it's an acronym, okay? It stands for something else. And you can, if you know that method, you can use that method. There's something else that's like a X method. If what I show today does not work for you and you find another method, by all means use it. By all means use it. Okay? All right. Now, I'm going to show two. So we're going to have a double distributive property. Double meaning what? Two. Yeah, double means, yeah. Type it in your phone. What does double mean? Okay, so now, all right. So what we're going to do is we're going to cut this first binomial into two pieces. Okay, we're going to slice like a ninja, cut like a razor blade. And we're going to put the first term here, and we're going to put the second term here. Okay, now I should have sliced a little bit better so I got that sign. Okay, but we get that sign and we put it in there too. Now we're actually going to multiply. Well, x times x is x squared plus 5x plus 2x plus 10. Okay? Now, all I did was the distributive property twice. I doubled it, like double trouble, double scoops, double stuffed. I know those that don't listen to regular radio, you've never heard this commercial that's got Jennifer Coolidge in it where she says, "Oh, I'm doubling everything." Yeah, double dating, double this, double this. Yeah. All right. Anyways, the only terms that we can connect or connect combine are these two. All right. So what is 5 plus 2? Are you sure? Okay, good. Remember, use for calculators are highly suggested in this class. All right. Now, that's one method. A lot of people like this, and a lot of people don't. Okay? It's like, and we're not going to go on a tirade about if pineapple belongs on a pizza. Well, it's whatever you want to put on there. You're eating it. If I don't like it, you're not forcing me to eat it. Okay? It's not like you're putting rutabagas on my pizza and making me eat it. I don't even know what a rutabaga tastes like. All right, so the box method, what I'm going to do is I'm going to take this first term, I'm going to do it right here. I always do mine this way. I always put the first one in the vertical. Okay. What? Got scared of the boxes? Well, flip it over because that's why you're not supposed to be on it. Oh, again, flip it over. All right, so, and then you can put this up here, x and then plus 5. Okay, now, what happens is when you put them in these boxes is that where they meet, that's where you combine them. Okay, like here should be the product of x times x. Yeah, so this would be x squared. This would be 5x. This would be 2x. And this would be 10. Now, something you should notice is that when you do the box method, this diagonal right here, that is where your like terms are, is in that diagonal. Uh, let me see if I can make that a little bit better. I doubt I can. All right. So when we go to write this, well, I know I'm going to have an x squared. Well, what's 2x plus 5? What's 2 plus 5? 7. And then 10. So again, we get the same answer either way. All right? We get the same answer either way. It doesn't matter which method. You just pick one. Okay? Now, I will tell you this. How you do these, okay, will also kind of determine what you do with stuff later on with factoring. Okay? It just works out that way. It kind of does. Okay? So, all right. Are we good here? Yes, no. Okay. All right. Now, would somebody mind getting the door? All right. So it says find the product. The product is the answer after you multiply two things. Did y'all know that? Okay, good answer. All right. So I'm going to set them up both ways. I'm not going to work them out both ways. I'm going to set them up both ways. So I'm going to cut this right here. I'm also going to write this like this. I'm going to copy this twice. Now, I'm setting this up both ways because about by now you may have already chosen which way you're going to do this. Some of y'all are still like, wait, there's math? Okay. Ah. And that's about how she goes. Now, yes, I did work out that problem in both methods very fast. Why did I do that? Because I can. Okay. But I, when we go over the your turn, all I'm going to write is like the terms and then the answer. I'm not going to set it up. I will go back and set it up based off of what your question is. Is like, hey, Mr. Jeffries, can you go back and work out this one with the box method? Hey, Mr. Jeffries, can you go back and work this one with the double distributed method? Hey, Mr. Jeffries, blah, 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 blah. Okay, that kind of thing. All right. How many of y'all like the double distributed method? How many of y'all are box method people? How many of y'all have not made a decision? Okay. Oh no. There's another number beside X in front. Does something change? No. Nothing changes. It's still the same process. I will try my best to not do both of them. Lightning McQueen. Ka-chow. Because you too can be like me. All right. So if you do double distributive, that's how it's going to look on the left. If you do it box method, that's how you're going to do it on the right. Now, kick in coffee. All right, that should help. Now, bless you. Some people like the box method because they like to have their stuff organized. Some people don't like the box method because they refuse to draw the box. And some people still don't have a clue about anything that's going on right now. Okay, so did you get that? Those look, the top green are the terms, what you should have got in either your chart or after you did double distributive. What I circled is what you should have got as your answer. All right. So what's harder, this stuff or what we did last week? Last week was hard. All right. Special cases, kind of like some of y'all. Oh. oh, now we have more people's head pop up. Okay. All right. Very good. All right. So Well, you should have seen it. It was like whack-a-mole when it all messes up and all the things come up at the same time, or the meerkat manner. Now, when something is squared, this means this. It is multiplied by itself. Okay? That power, some people are squinting to see that 2, which is also the same little 2 that's on their paper. Um, it's you're cloning that, okay? Just like the people on Camino that made the clone army for the Republic. Okay, so that was a Star Wars reference. So I cut it right here. I have x. I have -5. So how was math today?
Mr. Jeffries said that some of us were special cases.
He's probably right. Today at a red light, I sit there and watch this lady put her lip stuff on. I don't know. It looked kind of like a uh, color pencil that she was using, but she was like doing this and then doing this right here. And I was waiting to see if she would look over because I was going to give her a big thumbs up, but she never looked over. I just thought that would be super fun. All right. On top is what you should have got for your terms. What's circled is what you should have got for your final answer. Okay? Some of y'all are like, I got out of the bed for this. Yes, you did. Hey, just remember if you think this is bad, somebody got up today and got ready and went to work to do a full day of colonoscopies. When I'm having a bad day, that keeps things in perspective for me. All right. So here's another special case. We're going to give this special case a name here in a second. All right. So that parenthesis didn't have a lot of curve on it. Somebody says, well, why did you write 91? I didn't. I just apparently can't write today. All right. The top part, again, are your terms. The bottom part is your final answer. This, like I said, has a special name. Okay, this is called a dots problem. Okay, which stands for difference of two squares. Okay, and somebody like, well, what does that mean? Well, think about it. This x squared, that is a squared term. 81 is a perfect square. There's subtraction in the middle. The difference of two squares. So you'll see these a lot when we get into the next unit and or the unit after the unit next week. Yep. And you'll understand why we see these a lot. Well, because of perfect squares and why we use them. Oh no. All right. This this special case also has a name. This is a binomial times a trinomial. All right. A bi times a tri. Now, it is a binomial times a trinomial because this first term, this is a binomial because it's 2. This is a trinomial because it's 3. Okay? Now, the process really doesn't change. All right? Believe it or not. It's just a little bit of a fixer upper. Which I I think that song is very false to be saying to young people, if they're a fixer upper, you should, try to be with them and change them, no matter how many red flags they have. All right, now, think about it. This is a bigger type problem. Should this take a little bit longer? Yeah. Okay, but you can still do both methods. You can still do both methods. All right. So again, what's in green are your terms. Well, what's on top Stop yawning. Now, um, the next problem I think is set up in a way that you can actually rewrite this one. Yeah, because you can actually flip it. I had a student, let's see, fall of 21, that uh, they showed me that you could do this, or 21 or 22, and they said, yeah, you can. Hey, you can do this. This is actually easier because all your like terms are together. And I honestly never thought of it that way until they showed me. So, has everybody got this one down? Can I move on to number 6? Anybody? Okay, moving on. All right. So what they did for this one, which I thought was genius, is they split it like this. Like they would have rewrote number 5 to look like this, and they would have split it like this. Okay, uh, get up there. So this actually uses a triple distributed property. Okay, and for this one, you would still do the same thing. I mean, you could change the box if you wanted to, but I'm a man in the box. So I just want to show you this with this triple distributed property because all your like terms do end up being right beside each other. It's kind of neat. I know math can't be neat, but we can try. And that's the last one, right? Before your turn? Yeah. Yeah, you get the same answer. It doesn't matter. Yeah, there's tons of approaches. Okay, there's tons of approaches, and I don't want y'all to be tied down to one. Okay, I kind of want y'all to actually use YouTube for uh, good things. Uh, like I know I put it on here, and wouldn't you feel bad if some teacher is absent and they're actually using my videos for lessons for their students if when they're absent? Wouldn't you? Could you imagine there's some class somewhere in America that some teacher is absent, and then all of a sudden their kids are logging on into Schoology or something, and they are seeing my face and all my craziness and stuff. That's hilarious. But there are actually really good instructors that show stuff a lot different ways than me. And I like them better than Khan Academy because Khan Academy and some of these other things go into this theory and this, that, and the other. I like find the stuff that works for you. Okay. All right. That's our lesson. Don't forget, hit like, hit subscribe, hit the bell. Do not interrupt somebody if they're trying to help you. And just don't interrupt people, anyways. It's rude. Good stuff, good things. Roll Tide.